On our first site visit here, we were captivated by the original 1960s structure. It's exceptionally powerful, very beautiful in its weathered state, and it's very relevant to the history of this site. We felt also that it is an important part of the story of Sydney, an important part of Sydney's maritime heritage, and we really felt at that stage we needed to look at keeping it. Surprisingly, for its maritime location, the existing steel was in very good condition. Of great benefit to our concept is it could be left in its weathered state, and it had stability or stable life in it for the next 25 years with very little corrosion rectification. In addition to the heritage story of this building, the environmental story of retaining this structure is really important. The cost and the energy to remove such an enormous structure like this is in the order of $2 million. And this building was on a strict budget, and certainly retaining this structure and reusing the structure to support the building was a very important part of that. It was very important to us to express our new contemporary overlay to this original structure, and so our new elements are freshly painted, and it's just wonderful that the original structure is in its weathered and original ageing state. This is one of the original gantry structure columns that we've left in its original weathered state. You can see here the corrosion that's evident on it has all been assessed, and it is a stable structure, it's not an issue. But for us it clearly articulates original to our new introducer, our overlay of contemporary elements. And all of our new structure is articulated of it, either bolted or welded as the case may be. These are the major roof purlins here that fold up and across, simply bolted to the side and welded to the side. And then also elements like what we're standing on here, this walkway, is again simply bolted to those original gantry columns. The most recognisable feature is this contemporary floating roof that we have draped over a gantry structure. We've hung from a crane structure basically, and we've let this billow and fold into the space.
The architect wanted as much exaggeration as they could get in the leading edge, which was what you see from the water, to create the wave look that they were after. But we needed to be able to drain all of the rain to the back wall, and so that ends up with a shape that is a good deal more exaggerated on this side than it is on the other. Now the consequence of that is the total length of the front edge is quite a lot longer than the total length of the back edge. The purlins are curved. They provide the fundamental shape to the structure. There was a fair bit of work to start off with what's called a spline, which is a free-form mathematical shape that the architect uses, and then turn that into a series of lines and arcs that the fabricator could actually roll and build to. And so we had to come up with an alternate geometry that was sufficiently similar to the original geometry, but was then a lot more practical to build. We also needed to make sure that we were developing the detail at the same time the architect was still looking at very much big picture shape effects. So that required a very close coupling of us as the engineer with the architect, and then finally with the builder, to do all of those things within a tight schedule. We used our computer model to generate a rapid prototyping model that was then used in the wind tunnel to give us pressure tap values across the entire roof and get a lot better understanding of how the wind would behave around a curved roof like this with a large ship next to it in its environment. We found downdraft loads that were quite significant, that you wouldn't by traditional design have expected, but you don't normally have a ship that's 3 times higher than the building itself parked immediately adjacent to a building. So it's not a normal wind loading that you would find, but it is critical to the strength of the building.
From a conceptual point of view, the context requires steel. It's a steel building we're starting with. It's a port environment. It's a very tough, very harsh marine environment here. Also, the spans that we were we're talking about, the most efficient material to work with was steel. And in fact, there's very little steel in this building. The spans of the roof are 12 metres between the purlins, so it's a very efficient and very logical structure. Because of its lyrical form, steel was an obvious choice to achieve those curves and to bend the major purlin elements through here. So it's quite complex in its geometry, but translating that from drawings and 3D models into a built form was quite a straightforward process. And what's arrived on site is very, very close to our drawings. The tolerances were very tight. What I really delight with in this building is the internal space. But the one concern we had is the size of the space. It's 90 metres long and over 40 metres wide in a very industrial setting. And the challenge was always to make this a warm and welcoming space for international visitors and domestic visitors as their arrival point into Sydney. And we are really, really chuffed with just how beautiful this space is at any time of the day. It's very respectful to the context, to the original structure, and it's what I like. It appears quite effortless in how it's been executed. So the simplicity of it, combined with the drama of the roof elements and the views, we're very happy with.